Hello everyone, myself Dr. Prasad Puthiyillam. Welcome back to my class series on chemistry for computer science and engineering under VTU Technology University. Very recently, you can check the date of my video recording. The syllabus scheme, the subject code has been changed. Earlier it was CHES102 or 22. Now they changed it to BCHES102. That is for first semester chemistry for computer science and engineering. Or if you are opting this subject chemistry for CSE in second semester, then it becomes BCHES202. This is only for the engineering students, comes under the stream of computer science and engineering, like computer science and engineering, information science and engineering, artificial intelligence and machine learning, artificial and data science, design or business system. So many courses are there under computer science and stream. So this particular class it is for chemistry of computer science, actually part 4. Earlier part there is no change in the syllabus as such, so you can follow the same classes. This is part 4 of the same class series. Okay, so earlier I covered these many topic which is in blue color. Now this which is indicated in red color that I am covering in this particular class series. The remaining classes I will be continuing. Okay, so electrochemical sensors. Already explained about electrochemical sensors in previous class. This slide I took with some reference. I forgot to indicate the reference. A very good one which indicate that electrochemical sensors, there are different types. It indicates the different types which we use in our laboratories. Okay, if it is measuring a voltmeter, we call it as a potentiometer. If it is measuring ampere current, we call it as ampere in terms of ampere, we call it as amperometer. Or if it is measuring conductance, we call it as electrochemical or conductometric sensors. Okay, so this schematically represented. You can pause the video and check what are the different components present. Only the generally it is given. Different types are there. This is one of the type which is used for environmental measurement, environmental sample measurement. But the concept is the same, which is used for other applications. Okay, so coming to electrochemical sensor for the pharmaceuticals, measurement of pharmaceuticals, I'm just giving the important questions to the level 3 or level 4. This is one of the question which is revised Bloom's taxonomy level 3 question. What are electrochemical sensors and how they are used in the pharmaceutical industry? Another question, how do electrochemical sensors work and what are their applications in the pharmaceutical industry? Okay, so both the questions are level 3 questions. Usually we'll get a level 2 questions in normal case. Level 3 questions also maybe the level 4 questions are a little bit high standard. That also I am included in this particular class video. Like how do electrochemical sensors contribute to the quality control of pharmaceutical products and what are some examples of the applications in the pharmaceutical industry? That is a level 4 question. How do electrochemical sensors work and what are some examples of their applications in the pharmaceutical industry? Another level 4 question. Okay, so based on these questions, I prepared my study material for this class. Okay, first point is given in point wise. It is not nothing to do with that 1, 2, 3. Just to identify the different points, I made point wise. Okay, by seeing the points, you can answer all the 4 questions which is given in the previous slides. So electrochemical sensor, they are devices which is use chemical reactions to produce an electrical signal that can be measured and quantified. That is the meaning of that electrochemical. So it uses chemical reactions. It also uses the electron movement, the electrical signal. These are combined and made a device to measure different samples. Here we are measuring the pharmaceutical samples. Okay, so basic component of an electrochemical sensor, it includes electrodes, reference electrode and electrolyte solution. So usually you should have a working electrode. Working electrode means which will sense, which will detect the changes in the environment or changes in the chemicals which we are measuring, which we call as the analyte solution. Okay, it also have a reference electrode because with the reference to something only we can measure something. Therefore, a reference electrode is also there and the electrolyte solution. The electrode is the sensing element which react with the analyte of the interest. Analyte of interest means what we want to measure the sample. It produces electrical signal which is proportional to the concentration of the analyte. They work by measuring the changes in the electrical properties such as voltage, then we call it as potentiometer, current, or resistance, which occur when an electroactive species interact with the electrode surface. If any interaction is there on the surface of the electrode, it can be detected. The movement of electrons will be there, that can be detected or can be measured accurately. This interaction can be either a redox reaction which involves the transfer of electrons, or a non-redox reaction which involves the transfer of ions. So redox reaction means a chemical reaction in which one component undergoing oxidation and other component going redox reaction simultaneously. One is undergoing oxidation and the other one is undergoing reduction. That is change in oxidation state. Usually in chemistry we write with the element top, either positive charge or negative. Say example, copper plus 1. When copper plus 1 becomes copper plus 2, we know when electrons are moved from that copper orbital, then it gets one more positive charge, means electrons are moved. Movement of electrons are there, like that negative charges are also there. So one is getting oxidized, the other one is getting reduced, which involves the movement of electrons. Then only it can be measured under redox reaction, in which electron movement is there. Even non-redox reaction is there, which also can be measured, in which there is a movement of ions or transfer of ions as such. Ions are transferred from one side to the other side. Ions as such is moving. When ions are moving, positive charge ions are moving, which gives a feeling of movement of negative charge on the opposite direction, and vice versa. Then electrochemical sensors are commonly used in pharmaceutical industry for quality control, monitoring, analysis of drugs and pharmaceuticals. It can detect various parameters such as the pH of the solution, temperature, concentration of ions, the presence of different molecules, presence of different gases can be measured. Electrochemical sensors, they are sensitive, they are very reliable, and provide real-time data. Means one set will get within seconds we'll get the result, and why if any changes are happening, that also it will show. So we'll be getting the real-time data, making them valuable tool for ensuring the quality and consistency of pharmaceutical product. Because in the industry which makes different drugs, different medicinal drugs, there the process happening in the reactors, if any changes are there, that will affect the drug which is made for some particular application, for some particular disease. If any changes in the composition or anything happens, it will not be giving the duty which is assigned to that drug, so it will be poisoned. So to avoid that, we should have the real-time data in the industry, industrial process. The applications of electrochemical sensor in pharmaceutical. One common application of electrochemical sensor in pharmaceutical industry is for the determination of drug concentration in the biological fluids such as blood, urine, or therapeutic drug monitoring. Means we need to check if any drug is taken or drug is administered either by injecting or by eating the tablet, or by drinking that medicinal liquid form. It will go to the bloodstream of our body, and through the bloodstream it reaches the place where it has to act. The particular cell is affected in particular area, then through the bloodstream it will travel, it will reach there, and it will react with the unwanted or the microbes, or the unnecessary cell growth, cancer as such, if it is there. So it is used, the electrochemical sensors are mainly used in pharmacy industry to measure how much concentration of these biological fluids, are the drug present in the biological fluids, like blood, not only blood, even urine is also treated as a biological fluid. And to measure the therapeutic drug monitoring. Therapeutic drug monitoring means for our body to uh, cure, or to fight, for the drug to fight with the microbes, we have to maintain certain drug level in our blood or urine. A certain level of drug has to be maintained, which we call as therapeutic level. The therapeutic level has to be maintained. For that purpose, we have to monitor, continuously monitor. So that we call as the therapeutic drug monitoring. Electrochemical sensors are also useful in the development of new pharmaceuticals, as they can be used to optimize drug formulations and assess the stability of drug during storage. Okay, so the drug formulations, when we make a drug, say called a tab or a capsule or even a liquid form, it has not only the drug content, it has got some other supportive materials also added to that to make it more useful. So some drugs, for if you give to some tonic we given to kids, they are sweet in taste, because otherwise the baby they want to drink it. Means it consists of many other components which gives the sweet, which gives the smell. All those has to be added along with the drug. Then we call it as the drug formulation. As well as it has to be stable, it should not get destroyed, it should not undergo any reaction with the atmosphere or anything which is in contact with the storage device. Okay, where we store the drug, therefore we have to check the stability of the drug for a minimum specified storage, which will be mentioned in that package as such, the date till when we can use that drug. So till then it has to be in a good form. We should give the same property as it is intended to give, so that we call as the storage, the stability of the drug during the storage. Electrochemical sensor can also be used to monitor the purity of drugs and identify the presence of impurities or contaminants. Okay, so when we prepare a drug formulation, the purity, there should not be any other material present which will affect the drug, or any other material present along with the drug which will cause some side effects for us than intended duty of the drug. If it is giving that impurities has to be identified, then only we can do some process to eliminate that. Electrochemical sensors can detect the presence of heavy metals such as lead or mercury in pharmaceutical formulations. Some metals we call it as heavy metals because the size of the ions are bigger than that of other metals. They are not good for our health. We cannot take too much content of lead to our body. We cannot take too much content of mercury to our body. Okay, so we need to detect the presence of heavy metals in pharmaceutical formulations. This is crucial because these substances can be harmful to human health. These heavy metals, if it is there, that will be harmful. So we have to detect whether it is there while preparing the drug formulation. Some amount of lead or mercury may be there. We have to control that it should not exceed. Some examples I am telling. It's not that we are adding lead to that or we are adding mercury to that. The possibility there will be content of lead or mercury or any other heavy metal, it will be harmful to human health, and it causes adverse effect. So this information of different impurities present or the therapeutic level or the presence of heavy metals, this information will help the healthcare professionals, those who are working in that field, to adjust the drug dosage, to adjust how much drug has to be given to for a particular disease, for a particular person, for a particular age group, how much drug dosage has to be given to identify or to come to a conclusion. The healthcare professionals like doctors or those who are handling those those who are supplying those drugs, they should know, so that therapeutic effect or minimizing adverse effect can be minimized. Adverse effect can be minimized. One limitation of electrochemical sensor, it is a need for calibration and maintenance, which requires skilled personnel and can be time consuming and costly. One of the limitation, not that electrochemical sensors are having no disadvantages. It has got some. You have to calibrate it. You have to keep it ready for measuring accurate results. That will be done with known samples. When non sample, we know how much is the concentration. So with the non samples, we have to do calibration and should give the result which is expected for that non-sample. Non-sample means we know that what is the reading should be given by the electrochemical sensor. That process is known as calibration. So calibration has to be done. The proper maintenance has to be done, because the sensor, electrochemical sensor, it has so many components, small components. which will be either undergoing a corrosion or some other poisoning may happen. Therefore, a skilled personnel, the one who is very skilled doing or operating such devices, they only can do that. So we need a skilled personnel, and takes a lot of time, and it is costly. Keep on calibrating in given a time interval, in a very short time interval, keep on calibrating. It is time consuming and costly, and everyone cannot do that process. Therefore it is costly. You have to send that electrochemical sensors back to the place where it is manufactured. There they will check it, they will send it back, so it will be costly as well as time consuming. The sensitivity and accuracy of electrochemical sensor can also be affected by interference from other substance present in the sample, requiring careful optimization of the sensor design and measurement conditions. We may be intended that electrochemical sensors to detect or qualitatively detect or quantitatively measure some particular drug or pharmaceutical component present in the sample, but some other substances, if it is there, it may interfere the sensing. Therefore different type of interference are possible, not in one particular sample one interference if you expect, and if you do optimize accordingly, then if you use some other applications similar to other application, the interference will be with some other substance. Therefore you have to understand what are the possible interferences are possible, and you have to optimize the sensor. Based on that, we have to change, modify the sensor to get a better measurement. Based on the measurement conditions, we have to design the sensor, and we have to get it. We should get the proper results. Despite these limitations, the electrochemical sensors have been widely adopted in the pharmaceutical industry due to their versatility, reliability, and ability to provide real-time data, which is essential for ensuring the quality and the safety of pharmaceutical products. Okay, so than doing nothing, done something, electrochemical sensors are produced, which are sensing, which are giving result, and we are depending on that, giving something better than nothing. Okay, not something, some small limitations are there which can be overcome, but we reached to a level where we can do real time analysis of the pharmaceuticals. The recent advances in nanotechnology and nanomaterials, which are enabled the development of miniaturized electrochemical sensors, which are very small, which are portable and cost effective. Okay, so we know what is nanotechnology, nanomaterials. They are very small in size. Excellent properties are given by nanomaterials than the bulk material or the micro materials that we used earlier. Therefore, by using nanotechnology, the technology itself makes the devices to be very small, handy instruments we can have. It is portable when it is handy, a small instrument, then we can carry it to any place where we want to do the analysis. Then it becomes a cost effective also. These sensors can be integrated into point-of-care devices for rapid and accurate diagnosis and monitoring of various diseases. These sensors can be connected to some other devices which is used. Okay, along with the other measurement, it will do the pharmaceutical sample measurement also. Therefore, integrating with the other instrument is also possible. They have in numerous applications in personalized medicine, allowing for real-time monitoring of patient health and the effectiveness of drug treatments. Now, electrochemical sensor for surfactants. uh, Questions I'm giving first. Compare and contrast the use of electrochemical sensors with other types of sensor for the detection of surfactants. It's a level 4 question. Okay, because electrochemical sensor for surfactants or electrochemical for pharmaceuticals, almost same concept is there. So surfactants, when it comes the same explanation I can give. Therefore, I took it to a level 4 level, so that much more information I can add on to that. One more question I added: what are some of the major challenges in developing effective electrochemical sensors for the detection of surfactants, and how can these challenges be addressed? Okay. So as I said, the electrochemical sensor for the detection of pharmaceuticals or detection of surfactants, the concept is almost same. The only the analyte is different. There we are measuring the pharmaceutical component, pharmaceutical sample. Here the sample is a surfactants. Surfactant means surface active agents. Uh, Mainly they used in detergents, shampoos, cosmetics, which are, should have a surface active element should be there. With detergents, we know how they work in washing the clothes. If you add detergents, it will create the surface. It will create surface tension so that the mud particle will come up from the threads of the textiles or dress material. Shampoos, when we use mainly for our hairs, so anything which is there, mud particle there, it will come out easily. And on cosmetics we use, because cosmetics are also surface on the skin we are using, it will reduce the surface tension and improve the ability of a substance to even to mix also. Electrochemical sensors can detect surfactants in various applications, including the industrial process, water treatment, food and beverage industries. Electrochemical sensors can detect surfactants by measuring the changes in the electrical properties such as the current or voltage which occur when surfactants interact with the electrode surface. The same explanation which is given earlier. What is electrochemical sensor? The component, the sample that you are measuring, here it is surfactant. We should have some changes near to the electrode which we use, the uh, detecting electrode which we use. Then with the reference to the reference electrode, we can measure the change. For instance, the anionic surfactants can increase the negative charge of the electrode surface, while cationic surfactants can create a positive charge. Okay, so a negative charge creating excess negative charge or creating excess positive charge means there is a movement of again the movement of electrons, or a possible circuit current is possible, which can be detected easily, and we can measure what is the amount of surfactants present in the sample. Therefore, understanding the physico-chemical properties of surfactants and their impact on the electrode surface is very crucial in developing the effective electrochemical sensor for the detection. Okay, any physical changes or chemical changes, that is physico-chemical properties. We should know exactly what is the physical properties of surfactants that we are going to measure. We should know the chemistry behind the surfactants, which chemical functional group is present in that, and what is the size of the ions present. If and all if you know, then it will be very easy for developing a electrochemical sensor for their detection. Electrochemical sensors are often more sensitive and selective than other detection methods, making them a valuable tool for monitoring surfactant concentration in complex matrices. Even if the sample is very complex sample, there also we can have a better detection. Electrochemical sensors can also be more cost effective and simple to operate than other types of sensors, making them suitable for on-site monitoring. On-site monitoring means where we want to do not only bringing the sample to the lab and measuring, we can carry the sensor or device to the site where we want to measure the presence of the surfactant. Some examples of surfactant detection methods using electrochemical sensors include cyclic voltammetry, amperometry, and impedance spectroscopy. Based on what we measure, either volt measured or ampere is measured, or the impedance is measured. Based on that, we can have different types. Only the schematic diagram given here, cyclic voltammetry, the schematic working, it is has got a counter electrode, a reference electrode, and a working electrode, and different closures. The electrodes are connected to a potentiostat, and these are the types of reading we are getting in the cyclic voltammetry. Based on that, whatever graph we obtained, we can analyze which type of a surfactant is present, whether it is present or not, it can be measured. This is amperometry. One example is given. There are so many different amperometric instruments available. One I took from the net. It consists of a anode, a cathode, a ammeter, and a battery connected to that. Potential difference generator is developed, and electrolyte is kept semi-permeable membrane. Then it is connected to the sample to which we want to analyze. So based on that, movement of ions through the semi-permeable membrane and changes in the ammeter reading will give the results. Impedance spectroscopy is also given here. The impedance spectroscopy, how it comes, that is indicated here graphically. Electrodes usually we are using a reference standard electrode. A silver chloride electrode is used here. Okay, then EMF is measured. A reference electrode is kept. Fridge electrode is kept through a capillary ion selective membranes are there. The analyte solution it will measure, and the impedance will be measured and plot the graph based on the graph reference graph we can measure the changes. And the construction it is indicated here. It consists of a copper is the wire which is used here. Silver chloride electrode, potassium chloride electrolyte, the analyte solution, then connected to select ion selective membrane, that is through the capillary. And potassium chloride is there. Silver chloride is silver is there, which is the reference electrode. Again, it is connected to copper. Okay, so that is the representation of the cell. Electrochemical sensors can be used to monitor the stability and degradation of surfactants over time, which is important for ensuring product quality and safety. They can also be used for real-time monitoring of surfactants in industrial process, allowing for rapid detection of contamination and potential quality issues. Okay, that is real-time measurement mainly in the industry, which makes the surfactants. Some surfactants also has to be pure, like detergents. No other components should be present there. Therefore, any contamination that also can be measured. Limitations. Certain limitations are mentioned. Developing effective electrochemical sensor for the detection of surfactants can be challenging due to several factors. One major challenge is the complex and dynamic nature of surfactant system, which can lead to the interferences, falling, or other adverse effect on the performance of the sensor. So we know the chemistry of surfactant. It has got a positive charged head and a long tail. It has got a head tail concept. Okay, so both charges are present in a single molecule system. It's a complex molecule, not a simple molecule like H2 or water. H2 water we call it as H2O, the simplest molecule. But surfactants, the molecules are a little bit complex molecules. Each surfactant molecule has its own complex nature. Based on that, because of the complexity nature of the surfactant system, many other possible interferences are possible, which gives a false result possibilities are there in the detection using the sensor. It can be they can be sensitive to interference from other electroactive species in the sample, which can lead to false positive or false negative result. There may be other impurities present which are also active towards the electrode. We call it as electroactive species. Okay, I'll repeat it. Any other material of any other component present in the sample which are also active, which are also will give some electron movement, which will be detected by the electrode. Then we call it as electroactive species. If they are present, it also will give either false positive result or false negative results. Additionally, the electrochemical response of the sensor can be affected by the changes in the pH, changes in the temperature, and other environmental factors. Therefore, a careful calibration and monitoring is required based on the condition. If we feel that there is a possibility of changes of pH, then we have to calibrate it. If the possibilities, sudden changes in temperature is there, then also we have to do calibration in before use. We have to calibrate it. Therefore, this calibration and it is required, which is one of the limitation of electrochemical sensors if there is a changes in pH or temperature. Additionally, the surfactants can have varying physicochemical properties such as the size, shape, charge, which can impact their detection by the sensor. Okay, as I said, a complex nature only. Uh, Different surfactants, the molecules are different sized, a different shape, they have different charges, possible charges, and it will impact the detection. Okay, one surfactant molecule, if you have a one particular surfactant molecule, if you have a sensor, it may not be so accurate for the other surfactant molecule. Therefore, we have to consider all the possibilities. Different sizes comes, how the sensor will adjust. Different shaped molecules comes, how it the sensor the device how it adjust, or the based on the number of charges. Okay, surfactants has got positive negative charges are present. Now, based on the charges also, the sensor has to adjust and should give the accurate results. Finally, the electrochemical sensors may require careful calibration and optimization to achieve the desired sensitivity, selectivity, and stability, which can be time consuming and resource intensive. Okay, so the sensitivity, how easily it will sense the surfactants present, selectivity, how the sensor will select a particular surfactant, not the other surfactant for other component present in that. Stability, how long the sensor will work without getting destroyed or without getting poisoned, that is the stability. These considerations, getting this accuracy, it will be time consuming to keep it ready for that, and it is resource intensive. We should have a particular a person, one who is expert in that field should be required. The materials which we use for the sensors, that also too accurately we have to monitor, therefore it is a resource intensive. Addressing the limitations of challenges. To address these challenges, several strategies can be employed. For example, use of a specific electrode material or surface modification can help to enhance the sensitivity and selectivity of the sensor towards certain type of surfactants. Okay, we'll take the examples. Okay, not given. Okay, let's explain this one. Use of specific electrode material or surface modifications. You have to identify a electrode, a material which is used to make the electrode. It should be too specific and it should be having high sensitivity towards a particular surfactant, then it will work. Or we should have some surface modification on the electrode. Surface modification means some chemical modification, adding some functional group like thiol or amine group or other which are too sensitive to easily, which will detect the movement of ions or charges present in the solution. Then it can be enhanced, the sensitivity and the selectivity can be enhanced. Additionally, the use of advanced data analysis techniques such as the machine learning or chemometrics can help to reduce the effect of interference and improve the accuracy of the sensor. Okay, what is chemometric? That is given in next slide, that's why I underlined it. Just a note that chemometrics is a field of study, involves the use of mathematical and statistical methods to analyze the chemical data. That means already measured or theoretically possible data are if present, matching that data, uh, the data are connected to the present sensing. When we use the sensor, it will then again it will check with the available data, then give the result, not simply just measuring and giving that, giving the result. It will compare with the possible related data which is already available, then after that only it will give a result which will improve the accuracy. It is an interdisciplinary field which combines the chemistry, mathematics, statistics to develop and apply methods for interpreting the complex chemical data. Continuing, finally, the designing the sensor with a suitable control mechanism such as pH regulation or flow control can help to minimize the fouling or other adverse effect on sensor performance. Okay, if it have the ability to regulate the pH changes in pH, if it can adjust to that. For the flow control, where we measuring the sample, there is a flow of ions, flow of electrons, or when we are measuring in a real time analysis in industry where the surfactants are prepared to be flowing from one reactor to the other reactor. In between we have to have the sensors kept. So a proper flow control, if it is there, then all those can affect the sensors performance. So we should have a proper readiness for that. Again, advances in nanotechnology led to the development of miniaturized electrochemical sensors, which are portable, low cost, and highly sensitive, making them ideal for field applications. The same given in under the pharmaceutical also. Overall, electrochemical sensors are valuable tools for the detection and monitoring of surfactants, playing a critical role in ensuring the product quality, the safety of the product, and the environmental protection. Next, electrochemical sensor for hydrocarbons. Okay, again similar one, but the analyte what we want to measure is hydrocarbons. So some questions I took. How do electrochemical sensors detect hydrocarbons, and what are some common types of electrochemical sensors used for hydrocarbon detection? Level 3 question. What are the key factors that affect the performance of electrochemical sensors for hydrocarbon detection, and how can these factors be addressed? Again, level 3 question. How can the sensitivity of electrochemical sensor for hydrocarbon detection be improved, and what are some limitations of these sensors? This is a level 4 question. How can electrochemical sensors be used for the detection and quantification of hydrocarbons in complex sample matrices such as crude oil or contaminated soil? And what are the key challenges associated with these applications? Again, level 4 question. So my points, notes which I prepared will cover all these 4 questions. Hydrocarbons, they are hydrocarbons, we know they are having hydrogen and carbon present together. Okay, we call them as hydrocarbons, a molecule which contains both hydrogen and carbon, we call that as hydrocarbon. Many other elements also can be present, but it should have hydrogen and carbon should be there. The simplest example is methane, CH4, carbon is there, for hydrogen is there. There are many other materials which comes under hydrocarbons. Alcohol, CH3OH, consists of carbon, hydrogen, oxygen also present. Okay, so hydrocarbons are commonly found in petroleum products. Mainly the hydrocarbons, different hydrocarbons we derive from petroleum products, fuels, solvents, and other industrial and consumer products, and can pose a significant risk to human health and environment. If we are not properly managing it, they are not so good for our health. It will cause some poisoning effect to our body. Therefore, handling those petroleum products, fuels, solvents, other consumer products, some cream that we use, all this contains these hydrocarbons. So we have to monitor such a way that which are poisonous to our body should not be present there, which are less poisonous. Anyhow, chemicals when we use, they are having some sort of poisonous will be there. Therefore, we have to avoid or minimize that poisonous effect. Electrochemical sensors can be used to detect and quantify hydrocarbons in various complex sample matrices such as crude oil or contaminated soil, air, and water. Electrochemical sensors for hydrocarbon detections are widely used in environmental monitoring, industrial process control, and other applications, and can provide rapid and real-time information on the concentration and distribution of hydrocarbons. So normal environmental monitoring, whether the an environment, a particular environment, mainly in industry, industrial environment is always feel hazardous. Okay, even not only environment, the places where more human population is there, they should we should keep on monitoring that if any hazardous materials are released to the environment or not. So for the monitoring, we should have a sensor. In industrial process control, during industrial process when we do some chemical reaction, chemical industries, so many chemical reactions happening. There we should know which hydrocarbon is present or any new hydrocarbons are getting derivated from that, explosive hydrocarbons are getting formed or not, that and all we have to check. So the process control also we need electrochemical sensors. And other application, that is real-time application information on the concentration and the distribution of hydrocarbons is very important. Electrochemical sensors detect hydrocarbons by measuring the current or potential generated when hydrocarbon molecules are oxidized or reduced at the electrode surface. Again, same explanation which I given in the first slide. Electrochemical sensor, how they work. There should be some reduction oxidation reaction, or there should be some movement of ions. Then only detection is possible. This process is based on the transfer of electrons between the electrode and the hydrocarbon molecule, which generates a measurable signal. Different types of sensors which are used. There are several types of electrochemical sensors commonly used for hydrocarbon detection. One type is the amperometric sensors, we already seen, which measures the current generated by the oxidation or reduction of hydrocarbon molecule at the electrode surface. A second, another type is the potentiometric sensor, which measures the potential difference between two electrodes in contact with the hydrocarbon solution. It has got a working electrode, a reference electrode connected to potentiostat, and measures the changes in potential because of the presence of the hydrocarbon sample. Conductometric sensors, which measure the changes in conductivity of the solution as a result of the presence of hydrocarbons. There will be changes in conduction property, then that also can be measured, and we can identify which hydrocarbon is present there. Each type of electrochemical sensor has its own advantages and limitations depending upon the specific application. So a potentiometric sensor, which is given here, if we normally this type of sensor we use in our lab itself, this is a schematic representation took from some reference papers. It has got a reference electrode, a working electrode, which will sense analyte solution, the sample, say here hydrocarbon. Any sample which you want to measure can be taken inside, then through the semi-permeable membrane, the potential differences will be measured by the potentiostat, and will give the we can measure what type of hydrocarbon present in that. This is a schematic representation. Different designs can be made based on this concept. No need to take the same type of say two vessel and semi-permeable. It's the same concept. It can be designed in a different way to have these type of sensing applications. Conductometric sensors, two platinum plates or two plates which can give the changes in the presence of ions, positive or negative ions present that which produces the movement of electrons to the external circuit, which will be measured. So this is again a schematic representation. Different models or different design can be made, different sensors can be made with this concept. The factors which influencing the hydrocarbon electrochemical sensors. The preference of electrochemical sensor for hydrocarbon detection can be affected by various factors, including the composition, complexity of the sample matrix, the presence of other organic or inorganic species, the temperature, variation in temperature, variation in pH. It can be lead to interference or false signals, which can compromise the accuracy and reliability of hydrocarbon detection. Our sensor will be compromised. Compromised means it will give false result. It will not give the result which we are told to them to give. It is compromised with the interfering. They are compromised. Okay, so it will give false result. That is the meaning of the sentence. Addressing the limitations and challenges. To address these challenges, several strategies can be employed depending upon the specific applications. Like one approach is to optimize the electrode material and design to enhance the sensitivity and selectivity of the sensor. We have to choose a material which is so accurate to measure the particular hydrocarbon. So we have to design the material, the electrode material, such a way that will give better results. The sensitivity of electrochemical sensor for hydrocarbon detection, it can be improved by increasing the surface area and reactivity of the electrode, as well as optimizing the sensor configuration and operational parameters. Uh, we have to increase the surface area. Surface area means if you use an electrode, the electrode which is having how much the surface which is active, you have to increase the active surface area so that more surface is there to detect the hydrocarbon present or the sample which the ions or the say hydrocarbon only. To detect the hydrocarbon, more area is there, which active surface area is there to measure the changes in the hydrocarbon concentration or changes in hydrocarbon itself. One approach is to use electrode material with high specific surface area and good conductivity, such as carbon nanotubes or graphene, which can enhance the absorption and catalytic activity of hydrocarbon molecules. So carbon and CNTs, different type of CNTs are multi-wall carbon nanotubes, single wall carbon nanotubes. These are having a high surface area and they are very good conductors. Okay, they are nanomaterial, very small materials. So in a given surface, there are so many active surfaces will be there, like graphene also. Uh, they are having better absorption properties also. They absorb. fastly it will absorb the hydrocarbon, so that the reaction takes place or changes will be detected, and it can be measured. The catalytic activity, it also improves the electrocatalytic. You know what is catalyst? Catalysts are those which speed up the reaction. They are having also electrocatalytic activity towards the hydrocarbon molecule. Therefore, the detection will be very fast and accurate. Another strategy is to modify the electrode surface with the functional groups such as that can selectively absorb hydrocarbons such as thiol. Thiol means sulfur and SH functional group. Amine groups, that is NH2, nitrogen and hydrogen, we call it as amine group. Okay, so these functional groups, if you add or attach it to the surface of the electrode material, if it contains these functional groups, it will increase the specificity as well as sensitivity of the sensor. So better sensing is possible if you add such a functional group. Possibly if you can add such functional group, not so easy process. Just like we cannot take SH and paste, just like cut and paste, it's not possible. They should work little bit complicated procedures are there to get add these functional group to the electrode surface, but it is possible. People are working on that, and it is getting that. Another strategy is to use signal processing and data analysis technique to reduce the effect of interference and improve the signal to noise ratio of the sensor output. That means the other data, the mathematics or statistical data are used it as a reference material, and sensing that element, referring the data, then giving the result, improve the quality of the result. It can thus can include baseline correction, signal filtering, and pattern recognition techniques, which can extract relevant information from the sensor output and distinguish hydrocarbons from other species. Baseline correction means we know some particular impurity is present, they will give a particular value. Okay, so avoid that value or make nullify that values. Then whatever comes, that will be the result of our hydrocarbon. Here I am taken the example of hydrocarbon, the sample analyte. Okay, we call it as baseline corrections. Signal filtering, any signal which is given by the impurities. So if you know that a particular signal, a particular reading will be given by a particular impurity, filter that signal, then also will get accuracy. Pattern recognition technique, by seeing the pattern, the reading pattern, by measuring, recognizing the pattern which is given by the impurities, avoid those, then again we'll be getting a better relevant information. So our output, the result will be better if you use all these different techniques, which is now possibly we can implement. In addition, the use of calibration standards and quality control procedures can ensure the accuracy and reproducibility of the sensor measurement. Okay, so we have to have a particular standard sample, accurate result giving sample, which the reading we have to consider. You have to maintain that standard, the temperature, the pH, whatever the factors affecting the pressure, everything we have to consider, and we have to have a calibration standard. And quality control procedures, other procedures to improve the quality of the measurement, will give better accuracy and will get a more reproducing result. Reproducing result means the result which is given for first time, second time when we check measure also should give the same result. Then we call it as reproducing results. This can involve the preparation of synthetic standards with a non-concentration hydrocarbons, that was explained, as well as the implementation of statistical control charts and outlier detection algorithms to monitor the sensor performance over time. In addition, the use of amplification techniques such as microfluidics or nanofabrication can increase the signal to noise ratio and the dynamic range of the sensor response, which can improve the sensitivity and accuracy of the measurement. Nanofabrication, microfluidics are explained in the next slide. Micro means we know the size. Fluid is not a liquid, not a solid, in between. We call it as fluids. Okay, that I'll explain in the next slide, which is underlined here. Okay, nanofabrication methods. Nanofabrication methods in fabricating. Say example here we need the electrode. Electrode, the surface of electrode is made with the devices which it will even go to the nano size, and the fabrication is done like a nano size fabrication is done, so that we can have more active surface area, more active surfaces can be made with the nano fabrication method. Different methods are there which comes under nano fabrication. So different subject area. So simply I'm explaining that nano fabrication methods will give more surface area, more accurate surfaces than what we see with our naked eye. If you go zoom and check, we can see many active surfaces in the electrode. So it will increase the result. The signal to noise ratio. If any signal comes, it convert into the noise. Means giving the output. Okay, so these are improved accuracy measurements, improving the accuracy measurements. Now what microfluidics? It is measuring small volumes, micro level. That much small amount of volumes are used, and it is integrated with other devices. So, okay, so this microfluidic concept itself is very small volume, micro level volumes are used, and many other components are also connected to that one and made a device. One which we call as the lab on a chip, a very famous word, lab on a chip. You know, a chemistry lab, how big it is. Such type of a lab, a chemistry lab with all possible measuring instruments, not only the titration, means burette, pipette, other component, other instruments, the conductometer, pH meter, or voltmeter, ultra UV visible spectrophotometer, gas chromatography, all many devices are there which we use in a chemistry lab. All those present in a small chip. Yes, chip we know which we use in the electronics. We call it as lab on a chip concept, because we are handling microfluidic, very small amount of volumes are used. Therefore, measuring that small volume, we need a very small sensing sensor devices are which is needed, and controlling is also the effectiveness, the result accuracy is also better. For instance, the integration of microfluidic channels into the electrochemical sensor can enhance the mass transport of the analyte to the electrode surface, while the use of nanomaterials or nanoelectrodes can increase the sensitivity and the selectivity of the sensor. The development of portable and miniaturized electrochemical sensors has expanded the application of hydrocarbon detection in the field setting, such as oil spill response, air quality monitoring, and leak detection. Okay, no complicated words here. Recent advances in electrochemistry, material science, and nanotechnology have enabled the development of novel means new, and highly sensitive electrochemical sensors for hydrocarbon detection, such as graphene-based sensors, nanowire sensors, molecularly implemented polymers are used for better accuracy. The integration of electrochemical sensors with analytical techniques such as gas chromatography, mass spectroscopy can provide complementary information and improve the accuracy and reliability of hydrocarbon detection. So we can even integrate with along with gas chromatography or mass spectroscopy or other analysis method, we can connect the electrochemical sensor, so that not only they take the sensing, also give the results of that gas chromatography mass spectroscopy will improve the accuracy as well as the reliability of the hydrocarbon detection. So please do subscribe my YouTube channel, my intuition 4865, and support me. Okay, my intuition 4865 is my YouTube channel. Once again, thank you very much for watching.